Okay, so we're going to implement a linked list in our JavaScript. We have some boilerplates already here, which is the node, which is going to have the data, and we'll be able to connect to the next node. We can return the data in the node. We can get the next node from whichever node we are in. We can always go to the next one. And then we can set the next node also from this node. So like if you have a single node, you can say next. So I've got a user here who's using this user class. It's pretty much like we're just going to create a test user. In this case, that's me. And then I'm testing my linked list using jest. So if I just run npm test, it's gonna start running my tests, and then it's obviously gonna fail. We know we don't have this one. Yeah, so it's gonna tell us we don't have a linked list. So we know the test is all linked up. So we're gonna create a class called linked list. And in our constructor, I'm gonna change it up the way, instead of using the head, like if we passed it like a head and a tail like that, without defining any values for those, they're gonna be undefined. But the way I'm gonna do it, I want to pass in an actual now value so that I can consistently use my tests to where I can just check if the tail or the head is now. That's better. And then if somebody initiated a linked list without passing a head, that means it's still gonna be now. If that's the case, I'm gonna initialize the head. Yeah, actually in the constructor, since this is already now, we just make the head and the head equal to the head. And the tail equal to the tail. So if they pass something in, it's going to be whatever they pass in. If they don't, it's going to be the now value there.
Mm-hmm.
Okay. And the first thing we're going to do is add to the tail. Well, first, let's run this. If we run the test, okay, so we know we need a method size. We need a method add to tail. We need a remove from head. So we need all those methods. So I can prename them right there. So I know I need add to tail. And then we're going to add in the item. From the list of errors we got, I know I need the size. Then I need remove from head. And then I think there was another one which is search. Yeah, there's a search one. We need a search one. Okay, so let's add to the tail. Okay, how are we gonna do this?
At the item at the end, rotate and increase the length by 1.
So like if somebody passes in the item, the first thing is we're going to use that item to create a new node here. So we're going to create a node here. So we're going to say new node equals new. And then we're going to pass in the value, right? And then we're going to check if this linked list has a head. If it does, then there's stuff already in it. If it doesn't, you know that it's empty. So the way you check for that is you're going to inspect for the head. If we do it this way, it's going to be like, this is checking for undefined. But this head is also now, but I'm still going to be like explicitly check for now. I'll be doing this. That way, whenever I come back and look at it, I know exactly what I'm checking for. And then we know that if it's empty, that's going to be now, because we gave it now there. So
there's no undefined because we did it above?
The head is never going to be undefined because we forced it to be now.
Yeah, okay.
And then we're going to use that fact that this link can be now, can have now values, which is empty, or stuff in it. And then if you transfer that logic to other languages, it's transferred very well. Because if you are switching from undefined to Python it to be none, to C to be now, so it's easier to define it this way, right? If that's the case, we're going to make the head equal to the new node and the tail equal to the new node, right? Else, and this is where the mix-up happened yesterday. You want to set the current tail to point to the next before you make the next the new tail. That's where things just, where the loop, like it was always like stuck on the first position. So here you're going to make that tail to, yeah. In this case, we know this is the next node, right?
Right, next node.
Yeah, next node. So the next node will be equal
new
to
node.
Yeah.
Yeah.
Now you can do it this way. This is like interacting directly on the node attributes, but the best way of doing it is to use a method like here. It's just a good practice to do. So instead of setting it directly like that, here, I'm gonna use the method here and then pass in the new node. Okay. Any question why I chose this one instead of directly setting it? Any questions? Or any confusions on that?
None so far.
Huh?
No, but can you show me the methods we made up above, or we have one?
It's
We have get data.
So we have these helper methods. Get data.
No, okay.
So instead of interacting directly on the attributes themselves, we're using methods in here to interact with them. So like if I want to say this dot data, I just say get data, and then it will return the data. Setting the next node or returning the next node, it will just, I'll call get next node. It will go on the attributes and then just return whatever that is. And then that's the same thing I'm doing here. So
very clear.
Okay, clear? Thanks. And better way. Okay. Okay, and then once we set the tail, and the typo there, we're gonna make the new node the tail now. Yesterday we did it reversely, so that's why it was all messed up. Okay. Okay, once we do that, we can test it out. By the way, let's see if we can run our tests. Okay, so 3 passed and 5 failed, right? And we can also manually just test it out yesterday. So we can call a list. Right? We won't pass in anything there. So we can console log the list. Okay. I never saved it. It wants a new, you have to use the, all right, so the list is empty, right? The head is now, the tail is now. We can pass it in some initial value. By the way, let me change the way I'm doing this here, because if I pass in just one thing, it's not gonna, I'll say if head is now, then I'll make both of them. If the head is now, it's gonna be that. And then else, that means the head is not now. Else, if I'll check the tail. So that if the tail is now, but the head is given, I'm gonna make both of these the same. You see what I mean? Because if I pass in one thing and I haven't passed in the other thing, it's gonna be inaccurate. And then the case is where both of them are correct. And I'll do that. That's a lot of repetitive thing. Oh, I can just
Is
check.
it possible that head is not null and tail is null?
Yeah, that's why I did it. I did it this way. So actually, let me just check if the tail is now.
Okay.
If the tail is now, then both the head and the tail are going to be the same.
Right, right.
And then else, it's going to be the head or tail. Right. This is the better check. That way, if somebody doesn't pass in anything, they're both going to be now. If somebody passes in one thing, both of them are going to be the same. But if they pass in the head and the tail, they're all going to point to the right thing. That's just a quick fix, because I just noticed I can do something like that. And for this linked list, let's just start from 0. And then we're going to add 1. Okay, so the head and the tail are the same. And then I can add 2. So the head is the 1, the tail is 2, and the tail points to the now 1, but the head points to the 2 1, right? Then you can add a few numbers. And it doesn't even have to be numbers. It can be a user like you saw yesterday. It can be anything you want. Okay, then if we save that, so the head is 1, the tail is 8, like that, as you can see.
Mm-hmm.
And the tail points to now, the head points to 2.
Mm-hmm.
Cool. And then, yeah. Okay. So which is the next method we need to implement? Remove from head, right?
Mm-hmm.
So we're gonna first check if the list has a head. If it does, so if it doesn't, we'll just return now. We'll just return it. Okay. Otherwise, we can remove the head if we reach this position right here. And then the best way to do this is to get a copy of the head. Once we have that, then we're going to check if this head has an next. Because if it's the only thing in the linked list, once you delete it, the whole thing will be empty, right? So you just check if it's connected to something next. Check if it's got a next. And I think we have a method here.
Get next to node.
Yeah, we can, yeah. So the 2 ways of doing that, we can do head dot next node. That's one way where you directly access the property on the node. But we said the best way is to use the method, right?
Mm-hmm.
That method. Any questions on that? Is that confusing? Guys?
Nope, I got you. I understand. I'm watching something similar to what you have on Code Fellows. So it's similar to what you're doing here.
If now we're going to still use the same method of checking if the next one is pointing to is now. So that means we only have head, which is the same as a tail. So we have to reset the linked list to now. And the best way to do this is just to say this dot head is now.
No.
And this dot tail is now. Yeah. Otherwise, when we do the check and it's pointing to something else, the easiest way is to just assign the next node to the head. And there are two ways of doing this. The first one is this dot head is equal to head dot. We can do something like that, or read it off the node itself, but I prefer using the method like that, right? Right? Okay, and yeah. So once we're done with deleting it or reassigning the links, we can just retain whatever was the head node. And what's the best way? There are two ways. You can get the data off it. You can get the data like that, or we can use the method, right? And I prefer the method way, right? All right, now let's test it out. So we know we added one here, right? So we can get a copy. Which is the list dot remove from head, right? You know, we have that. Then we're going to remove head 2. And then we're going to console those things out. And head 2. Okay, so that makes sense. The first one was 1, so that's the one we removed, right? And the second one was 2, that's the one we removed. And then if we look in the list, where is the list? Linked list here, the head is now 3. And the last one, the tail is 8. So our remove from head is working, right? And then we can also run the test package to see if that works. We know we had 3 tests passing. Now we have 5 tests passing. Cool. So yeah, we need to implement. Okay, let me do the size because the size is easy, right? If I was going to do the size, how would I do it? Oh. Hmm? What strategy would I take?
Count header to tail.
Hmm? Say that again.
Traverse from header to tail and count.
Right. So we're going to keep track of the count and while we are traversing it. Does that make sense, April?
Yes, it says here to count equals 0. Yes. And then you do like a while loop, right? A while, and then it would be next node.
Right. So
right?
I'm going to grab the head and then I'll use it to like keep going until I reach the end, and I know the end is the tail which points to now. So I'm going to use that fact to do that. So I'm going to get a copy of the head, but instead of calling it head here, I'll just be, because I'm going to be traversing,
current.
I'll call it current.
Okay, this head. All right. So basically, because in here it says self, so this equals self. It doesn't matter what it's called, right? Okay, and then you're going to do a while the current, and then count plus equal 1.
Yeah, I'm going to use the fact that the current is going to either be something or now.
Right.
So as long as it's something, I'll be traversing. So I'll just say while current.
Okay.
And then while that's true, the first thing I'm going to first
count plus equal 1.
Yeah, I'll increase the count by 1. And then I'm going to reassign
the current node to current get next, or right. All right. I'm going to post this link that I'm following into the chat. Yeah.
Okay.
More information.
Right, and instead of accessing the attribute directly, I'm just using the helper function we made to get the next one. And then this is going to keep happening until it's now. And the list, so we just return the count here. And we know we have how many things? 8 things in here. So we've tested all that. So we just say count is, we're going to call our function right? And the count is 6. Why is the count 6?
We remove the 2 nodes from head.
Yep, right there. So we took them out, and the count is 6 now. And then if we tested it, if we ran our test, six of them passed. So we're making progress. We know we have 1 method to go, searching. Okay, so searching will be pretty much the same as this, right? And the only thing is we'll be comparing whatever we're looking at with a target. We know the search is going to have whatever you are trying to target, right?
So what we are returning is different. Like at size, we are returning the count, but at the search, we are returning the node itself. So
yeah, since if you're searching a list, you pretty much just want to check if the thing exists or not, because you already have whatever you're searching for, right? So you don't need to return the node. So the best thing to do is to return true or false.
Okay, so
because you already have the target thing. So
okay, so we are just I mean testing it is true or not, and if it is to just return the yeah, okay, I see.
Cool. There is the while loop of doing it like this, right? And then there's also I'm gonna do this because I think this is the most important one. So the first one, a while loop, just the same way as we traversed using the count. And then I'll obviously comment out one or the other one. Method 2 is using recursion. And that's the reason I say that the while loop or recursion, they're pretty much, they do the same thing, except it's how they do things that's different. Cool? All right, so let's do the easier one, which is using the while loop, right? So we're gonna get a copy of the current node you're looking at. And then we're gonna now start checking. Does the current node, because in the size, if we just check, wow, this is whatever, if it's now, the count is still gonna be 0. Like if there's nothing in the list, right? So it's gonna go straight to returning count. But in this case, we want to check if it's false or not. So we'll just quickly check if the current, actually we don't even need this because we can just go straight to checking current, right? Well, what I was thinking is if current is equal to now, then just do a return here, false. But we can do like a loop on top, a while loop, and then at the end of everything, just return false. Okay. Right. And then we can start the while loop here. Yeah, because if the current is false here or now, it's not gonna get in the while loop. So I don't need the check on top, right? Right? Right?
So will the while iterate whether or not there is the target? It will iterate from the head to the tail, right?
So I'm initializing the current on the head, and then I start traversing it using the while loop. If I reach here, that means something wrong happened. Oh, that means whatever you were checking, you haven't seen it. If you reach here, that means you have reached the end of the list and not found the target. So it's going to return false here. But if we meet the target, we're going to return true. And that's going to happen inside the while loop. So we're going to grab the current and then get
Data.
Yeah. And then we're going to check if that data equals the target. If it is, we return true, right? Right? And then this will just keep happening as you traverse the list. And if you reach the end of the list, you're gonna get out of the loop. And in order to start traversing that, we're just gonna do the same thing we did here, right? Reassign. Right? And this will keep happening until we do part of it. The first thing is let's test it out. So we know we have 6, right? 6 exists. So if we ran that, it says true. We know that 16 doesn't exist in the list, right? So if we ran that, false, right? And then if we ran our tests, we should have everything passing.
Okay, I have a question now. What is the time complexity of that search?
Nice question. Guys, she's asking this because she knows the answer already, but it's for you other guys. What's the time complexity of searching this list?
The best scenario is 1 and worst is n.
So what's the time complexity?
It makes n, I guess.
N. Yeah.
That is correct.
What about getting the size? What's the time complexity of getting the size?
Me or somebody else? I know the answer already, so I'll let somebody.
I think you know you're looking at the answers probably. What about the other guys?
All of n?
Yeah. What about adding to tell?
Constant?
Nice. Okay. Let's see. What else? Oh, okay. Now this is the other part. Okay. We did it using a while loop. Now let's use recursion to do the same thing. Okay, there we go. How will we do that? Okay, the first part we know we will need like a current, right? Right?
Mm-hmm.
Mm-hmm. And then how are we going to implement the recursion part? I thought the recursion one it's so awesome that I wanted to show you guys the wow version and then do the recursion one because you're going to see this in a lot of questions or problem solving this year. So if you're able to look at a problem from one angle and pull or solve it in another way, if you start doing that, that's going to help you solve any type of problem. You're going to brute force it and then make it look nice or redefine it. All right, so the recursion one is I'm going to use a helper function inside the search function. Kind of like the way you do quicksort, where you do helper functions in there. So yeah. So I'm going to call it search. I can call it anything, but I thought this makes sense. Search linked list, since we're searching the linked list. All right. And then I know that every time I'm searching it, I'm looking at a particular node. So I'll just give it the variable or the argument, the node argument. And then, yeah. So once I'm inside the node that's passed on, I'm going to check if this node, and then I'll use the help
Data.
function data is equal to
Target.
And then I'll just return true, right? Right. Let me even write out the base cases, because we know, I'll write them here. Whenever you're doing a recursion, it's a good idea to do the base, to write them down. So we know it's either we find the target, we return true, or the second base case is we don't find the target. So we return false. And then we get the head for the first node here, which is our current. And then we write our helper function to do recursion. And since this is going to be a recursive function, we have to initialize it. We have to run it outside here. Here, then we're going to like pass it in whatever the current node is, and then it will start recursively looping on itself. And then we need a return here. So that whenever it comes to the end, it's going to return something. So in the cases is either we found the target or we don't find the target. Oh, and then since, so like if we find the target here, it's going to return true here. But if we don't find, like if the target is not equal to that, it's just going to move on. It's not going to do this if statement. So because of that, if it reaches here, that means it's here. So we're going to now check the next one. The next node. So we're going to like continuously do this. And then at some point, the next one is going to be at the end of the list, and that's going to be now. Once we reach the end of the list, we know we've traversed the whole list, and we haven't found the target, so we're just going to return false.
False.
right? And that's the reason I also wanted to use now, because that's gonna, like, I'll be able to use it in those cases. And then inside the search linked list, we're recursively so we're going to call it inside again, and then we're going to return it. And remember, this node is this one we're on. So we're going to just pass it in the next one. Okay, let's make this run first, and then you guys can ask questions. Okay, so is oh, we didn't. Let's make 2 of them. Let's try 1. We know 1 was in the list, but we took it out. So is 1 in the list, and then 6 in the list. Okay. Okay. Does 1 exist in the list? No, we took it out by design. Does 6 exist in the list? True. Does 16 exist in the list? False. If we do an npm test, it passes. I thought the recursive way of doing it was awesome. Like, think about it. Look at that. And which is the same as the while loop, but I wanted to do this one. Any questions about the recursive one or the list itself?
So what is the best way to practice recursion?
You come across a problem like this, which you can solve in a way that you understand, like this, right? And then you attempted to do it this way, and you study. Like this one, when you look at it, you search, the best cases are, we find the target, return true. We don't find the target, we return false, right? Okay, so you know that part, you know this part. You're just grabbing the first node in the list, and then you're like, I guess just writing it a bunch of times, practicing.
Okay, I'll practice too. Yeah.
It looks complicated, but once you practice a bunch of times, you can do it.
Yeah, so slowly it is clicking in, but yeah, I still need to practice more. So
cool.
But you'll push this up to the link, the thing you have,
okay.
right? So we'll have the answer.
Yeah. Actually, let me. I've got these ones broken down into data structure in Python, C, and JavaScript. Like 3 folders. So if you go there, this one is going to be in the JavaScript one.
Okay, so you have 3 folders that have linked lists. One is Python, one is C, and one is JavaScript.
JavaScript.
Okay, so all we have to do is go into those 3 folders and clone them?
Yeah, I think you
okay.
cloned them. Didn't you clone them already?
I think I did. So it just goes automatically, it pushes up when you push it?
You have to pull the changes.
Okay.
But I'm about to push them out.
Okay. Because I like having this information on my Git. So if I want to go look back, which I will be doing slowly and surely.
And then, as you can see, you can add methods to this linked list. So if you want, you can add the way we did, like remove size. You can check for the max. You can remove from the tail. So yeah, remove from the tail, or add in the middle, or delete from the middle. So you can do all kinds of stuff. But the basic gist of it is a linked list is a node which is connected to the next node, right here. So it's got a data, and the next node connects to the next node, and it's terminated by a null pointer. So you can even have doubling.
Sorry. I was like, so if we were asked on an interview, what does a node list do? We would say that it links on to the next, goes through to each node, correct?
I would say it contains some data in the node and as a pointer to the next node. For a singly linked list, you can have a doubly linked list which points to the next one and the previous one. So the node can either point in one direction or it can point in both directions.
Okay.
Was that confusing?
No, that wasn't confusing. A double points in two, a single points to one. That's clear.
All right, and with a bunch of practice, you will get good at it. All right, thank you.
Thank you, Edward.
So what